Kia ora Year 11 and 12. This question is an excellence question from 2014, looking at where a function is decreasing. Okay, so here's the question. We're given a cubic, g of x, and we need to show where it's decreasing. So we can start by saying something like this. For a decreasing function, we need g dash of x less than or equal to 0. So the first thing we're going to do is differentiate, figure out where it's less than or equal to 0, and then check. So g dash of x is equal to, I'll do this slowly, so we've got 2/3, bring down the 3, x squared plus 3 over 2, bring down the 2, x minus 20, and we need that to be weakly negative. I'll go on to a new slide to clean that up. All right, so that gives me a quadratic. This is the quadratic. 2x squared plus 3x minus 20 is less than or equal to 0. So we need to factorise that. You can do it by inspection, or you can do it by grouping. So we want two numbers that times together to give me negative 40 and have a gap of 3. So 8 and 5 in some combo are going to work out. We're going to have 8 plus negative 5. And that'll work. And that tells me how to split up that 3x. So we get 2x squared plus 8x minus 5x minus 20 is less than or equal to 0. So 2x into x plus 4 minus 5 times x plus 4 is negative. 2x minus 5 times x plus 4 is negative. Right, so my critical values, my crossover points, are where 2x equals 5 or x equals negative 4. Right, I'm looking at each of those factors, giving me x is 5 over 2 or x equals negative 4. The easiest way to look at which bits of these regions is to graph that. Now we know that g dash of x is a quadratic. It's got a 2, so it's an up the right way quadratic. And one of the critical values is here, and the other one's over here. So graphing that, I can see that the region that I want is, let's see if I can change the pen colour. Here we are. I want this bit in here. So my answer is going to be that x has to be between negative 4 and 5 over 2. But it's good to check that we've got that right, and there are a couple of ways to do this, and they required this in the schedule for that year, so make sure you don't forget this step. Okay, so several ways to check. The first way is we can test a value. Now we've already done it, it's kind of overkill, but we can put in x equals 0 and check that we get a negative gradient there. So g dash of 0 is equal to 2 times 0 squared plus 3 times 0 minus 20, which is less than 0 as required. So we do want 0 to be in that range. The other thing we can do, which is quite nice, is to use the shape of the cubic. So g of x has this shape because it's what we call a positive cubic, and that means that the decreasing bit is going to be in the middle. Okay, so you can write that down in words, that's fine too, or you can check the second derivative, but I don't think that's a very good way to go for this question. Okay, so just make sure that you do show that you've checked that you've got the right region, and be really careful not to do things like this. So our two values are negative 4 and 5 over 2. Don't go writing crazy stupid things like this. Okay, so there is never a value of x for which that statement is true. Just read back and check that your inequality makes sense by substituting in a number. All right, thanks for watching. I'll be back with some more later on.